Your chunking strategy moves retrieval quality more than your embedding model does. Most teams tune the wrong knob. This is for engineers building Retrieval Augmented Generation (RAG) on Azure AI Search. A bad split can drop recall at 10 by 20 points on the same corpus. So stop guessing and measure it. We cover 3 things: fixed versus semantic versus recursive splitting, how to score retrieval, and the harness in Python. One of these splitters wins less often than you think. A chunk is the unit your retriever actually returns. Too large, and embeddings blur multiple topics together. Too small, and answers get split across chunks you never retrieve. The embedding model has a token ceiling, often around 8,000 tokens. But the real limit is semantic coherence, not the ceiling. Your chunk should hold one idea, plus enough context to stand alone. Overlap re-adds context at the boundaries. Hold that thought about overlap. It hides a cost trap I'll show later. Fixed splitting cuts every n tokens with fixed overlap. It's fast, cheap, and ignores meaning entirely. Recursive splitting tries separators in order, paragraphs, then sentences, then words. It respects structure like Markdown and code without extra cost. Semantic splitting embeds sentences, then cuts where meaning shifts. It produces the cleanest boundaries but costs embedding calls up front. My rule of thumb: recursive is the strong default. Semantic wins on messy, unstructured prose. Fixed is only a baseline to beat. You can't compare splitters without a ground truth set. Build questions paired with the passages that answer them. For each strategy, index the chunks, run the queries, and check the hits. Track recall at K. Did a relevant chunk appear in the top results? Track mean reciprocal rank for how high it ranked. Add normalized discounted cumulative gain if you have graded relevance. 50 labeled questions is enough to see real gaps. Keep the embedding model and K identical across runs. The harness is a loop over strategies. Each strategy writes to its own Azure AI Search index. Use a shared Azure OpenAI deployment for embeddings, so the only variable is the split. Blob storage holds your source documents and the labeled question set. Push vectors with the vector search profile enabled on each index. Then query all indexes with the same requests and diff the scores. Isolating one variable is the whole point. Same data, same model, different chunks only. Here's the core comparison in Python. Each splitter returns chunks. You embed them once and upload to its index. Then you replay every labeled query and check recall. The whole file fits in under 100 lines. Notice recall at K is just a set membership check on returned IDs. Now the traps. Overlap inflates your index. 30% overlap means 30% more vectors and storage cost. Semantic splitting's embedding calls happen at ingest, and they add up on large corpora. Reindexing on every content change gets expensive fast, so batch it. And retrieval scores can flip when you switch to hybrid or semantic ranking. Always test against the exact query pipeline you ship. A splitter that wins on pure vector search can lose with re-ranking on. Start with recursive splitting as your default and measure it. Build 50 labeled questions and score recall at K plus mean reciprocal rank. Only reach for semantic splitting if messy prose demands it. Always evaluate against your real hybrid or re-ranked pipeline. Never pure vectors alone. Prices and model limits shift, so confirm token ceilings in the current Azure docs. Clone the harness and run it on your own corpus this week. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.